Okay, so the experiment that we're going to be doing in this lab is written out here. Basically what's going to happen is that solid copper metal is going to react with aqueous silver 1 nitrate to yield copper 2 nitrate and silver metal. So your first question before we get started is to write a balanced chemical equation for the above reaction. So here is the balanced chemical equation for this reaction. So our solid copper metal is going to be reacting with aqueous silver 1 nitrate. Remember that the 1 means that silver has a plus charge. And from your polyatomic ion naming reference packet, you should know that nitrate has a -1 charge. So that means that silver nitrate is 1 silver and 1 nitrate ion. And those react together to yield aqueous copper 2 nitrate. So here, the 2 means that copper has a +2 charge. If nitrate has a -1 charge, then copper 2 nitrate is going to be 1 copper and 2 nitrate ions to balance out the charges there, as well as solid silver metal. And then in order to balance the equation, we're going to need 2 silver 1 nitrates and 2 silvers. Now for our second question, I want to know what type of reaction is this? So this reaction is a single replacement reaction, which remember it looks like this when we've got A plus BC and A kicks B out to form B plus AC. In this case, A is going to be the copper, B is the silver, C is the nitrate. Copper is going to sneak in and kick silver out and start dancing with nitrate to form AC, copper nitrate, and poor silver no longer has a dance partner and is going to have to go stand over on the side all by itself. All right, so here is the procedure that we're going to follow today. The first step, which I forgot to include when I first wrote this out, which is why it's step 0, is to weigh a piece of filter paper. The filter paper is what's going to collect our silver at the end of the experiment, and so in order to know how much silver we've collected, we need to know the mass of the filter paper. We're then going to cut and weigh an approximately 10 centimeter long piece of copper wire, and then we're also going to weigh out 1 scoop of silver 1 nitrate. Silver 1 nitrate is a white powder, but it's kind of interesting. It actually can stain your skin like this really dark black brownish color. It's also used sometimes in forensic science to do fingerprinting and to resolve fingerprints that are on things. So I'll have to be careful with it, otherwise I might end up with some stains on my skin. I'm going to place the silver nitrate in a beaker with about 100 milliliters of water. I'm then going to bend the copper wire so that it can be fully submerged in the silver nitrate solution, but I'm going to leave a handle sticking out. So I'll show you guys what this looks like when I actually do it. All right, so once you have your copper wire all ready to go, you place it in the silver nitrate solution. We're going to observe what happens. We'll see some signs of a chemical change happening. We're going to let it react for 20 to 30 minutes until it looks like no more reaction is happening. We want to make sure that the reaction goes to completion and that all of the limiting reagent reacts. Once we're done, we're going to remove any copper wire that is remaining, if any remains, and we're going to shake and rinse any silver that's left on there off. We're going to filter the silver out from solution, and then we're going to let it dry. And then once it's dry, we're going to weigh the dry silver on the filter paper to see how much silver we have produced. All right, so with that procedure in place, my question 3 for you that I want you to answer is what safety precautions do you think I need to take while completing this experiment? Now we're going to get our 3 measurements, our 3 before masses before we start the experiment. The first thing that we're going to measure is the filter paper, which looks like it is 1.46 grams. Okay, good. So we're going to set that aside. Oh, Neil's here to help. Neil, are you going to help do a chemistry experiment? Yeah. Are you going to be a chemist when you grow up? Of course he is. He has no choice. All right, so the second thing Poor kid. The second thing that I'm going to weigh is a piece of copper wire. Funny story, I've lost all of my rulers because Neil likes to play with them and hid them somewhere, so I'm going to have to just estimate 10 centimeters here. This looks about good. Alright, so we've got our piece of copper wire now, and so we're going to get the mass of that. So that looks like it is 0.48 grams. Alright, good. We'll set that to the side. And then the last thing that we are going to weigh is our silver nitrate. So again, remember, this is what can stain your skin, so I'm going to try and be careful.
Mommy, what's that?
That's copper wire.
Oh, what's that?
That's copper wire. Pretty cool, huh?
That's cool.
Yeah. I'm now going to weigh out 1 scoop of silver nitrate. No, don't touch. Don't touch. Don't touch. Thank you. All right. So this is about 2.05 grams. All right, good. So we have our data. We have our before measurements here. And so my next question for you all is if this amount of copper wire, so if 0.48 grams of copper reacts with 2.5 grams of silver nitrate, what is our limiting reactant going to be, and how much solid silver metal will we produce at the end? In order to answer this problem, hopefully you did 2 stoichiometry equations. The first one would be seeing how much silver is produced if 0.48 grams of copper reacts. You do the stoichiometry problem, and the answer that I got was 1.6 grams of silver. Paying attention to sig figs there. We have 2 sig figs to start with and the mass of the copper. So we have 2 sig figs in our mass of our silver. So if all of the copper that I just weighed out reacted, if all of it reacted, I should form 1.6 grams of silver at the end of the reaction. But we have to check to make sure that we have enough silver nitrate in order to get there. And when we do a second stoichiometry problem, starting with 2.05 grams of silver nitrate, we find that that amount of silver nitrate will only produce 1.01 grams of silver. This is less than 1.6 grams of silver, and so that means that silver nitrate is going to be our limiting reactant. That's the reactant that's going to run out first, and when it runs out, the reaction will stop and all of the copper will not react. That's going to be our excess reagent, and so that means that we're going to have some copper left over at the end of the experiment. And so this number here is actually going to serve as our theoretical mass. Now we're going to get this all set up. So the first thing that we're going to do is we're going to add our silver nitrate to the beaker. And be careful not to spill so that I don't get any on my fingers or all over my kitchen because, you know, lab safety. All right, and now I'm going to add 100 milliliters of water. Go. And I'm going to give it a stir to get all of the silver nitrate dissolved and in solution, because if it's not dissolved, it's not going to be able to react with the copper. Almost there. Alright, that looks pretty good. Okay. And so now what I'm going to do is I've bent my copper wire up here, if you can see it, into a little curlicue shape so that it'll fit inside. But again, I want some of it sticking out because I'm going to have to periodically shake off the silver that's forming on it. And I don't want to have to dunk my fingers into the silver nitrate solution because then I will have very dark brown stains all over my fingers. All right, so we're going to add the copper here to the silver nitrate. And I'm going to stop the video and turn on time lapse because we're going to let this sit and react for 20 to 30 minutes. All right, guys, so the reaction took a lot longer than I thought it would. My phone actually ran out of battery, so I was doing the time lapse. But you at least got to see most of it. I think, though, the reaction's done now. This has been sitting now for like an hour and a half. And you can see most of the copper has reacted, but I think there's still a little bit left inside there. Try and use, ooh, there we go, the scupula here to try and knock the silver off of the copper wire and see if we can pull this up and out. Ooh. There we go. So basically what I'm going to try and do now is I'm going to try and fish out any of the unreacted copper wire from the beaker so that we can then filter out the silver and dry it off to get the final mass. I was able to somewhat successfully filter the silver out of the solution. This is what it looks like. It kind of has like a dull, muddy color, but there's like a few little sparkles in there if you look closely. This is the solution that I filtered off. You'll notice that it's blue. That's because of the copper nitrate that was produced. It has a blue color. And you can also see that some of the silver got through. On the time lapse, you guys may have noticed that my impromptu funnel didn't work so well and kind of collapsed into my beaker during the process. So a little bit of silver escaped there. There's also still a little tiny bit of silver left in the beaker here. I tried to rinse it out with water, but I didn't, I forgot to bring the squirt bottle home from lab, so it's not perfect. But we got most of the silver, and so now the next step is to let it dry. I'm gonna put it in the oven for a little bit, and then we can get our final mass. So I just took the silver out of the oven. It's been in for a little bit, and it looks nice and dry now. And you can see that the silver is not clumpy anymore. It's nice and powdery and a little bit shinier than it was before. So let's go ahead and get a mass of our filter paper plus our silver. Put that on there. Let's see, 2.46, oh, 2.45, okay. So filter paper plus silver, oh, 2.46, okay, 2.46, let's go with that, grams. All right, so given the data that we have here, so the filter paper plus the silver is 2.46 grams. I want you guys to calculate how many grams of silver we made, so our experimental mass of silver. So by my calculations, if the filter paper and the silver weighed 2.46 grams, our filter paper, hi bud, was 1.46 grams, which gives us an even 1.00 grams of silver as our experimental mass of silver. And if you remember, our theoretical mass was 1.01 grams of silver. So we are pretty darn close. So your next step is, I want you guys to figure out what our percent error was for this experiment. All right, so Neil helped me with my calculations. You can see his contribution right there. But I got a 0.990% error, which is pretty awesome. I'm proud of ourselves. And so that leads me to my next question. What sources of error do you think could have led to these results, to us making a little bit less silver than what theoretically we should have? Thanks guys for doing this lab with me. As you can see, I got everything all cleaned up and I now have a nice little beaker of silver. I did get 2 stains on my hand from this experiment. You can see here is one and there is another. They'll come off after a couple of days, so not to worry. I hope you enjoyed this virtual lab. I wish we could have done it not virtually, but this will have to do for now.